Hello everyone, my name is Andrew Nguyen, and this is my AP Chemistry final project. So I'm just going to be talking about what I did, and it's going to be a little disorganized, so bear with me. So my experiment was determining the amount of vitamin C in different fruit juices. I'll talk about which fruit juices I chose later on. And so right now I'm measuring out potassium iodide to make a iodide solution with distilled water. And so I have 500 milliliters of distilled water in the flask there, and I'm just adding in the potassium iodide. Unfortunately, I did this wrong because since potassium iodide has mass, I ended up making the solution greater than 500 milliliters, so I had to do it over again. You can see the first time I had a very difficult time measuring out that potassium iodide. There's a lot of potential errors here at this point in the experiment. The weighing and measuring of water and all the other substances later on will always have a bit of error in them, so that's something to factor into the calculations. And also on the hot plate there is a starch solution. It's just some 250 milliliters of distilled water and a heaping spoonful of soluble starch. Nothing special there. That is going to be the indicator for the experiment. So in the actual reaction, vitamin C or ascorbic acid will react with iodine to form iodide ions and dihydroascorbic acid. And so once all the vitamin C is used up, then the iodine will react with the starch and it'll make the solution turn darker. So that allows me to determine what for one when all the vitamin C is consumed, and so from there I can determine how many moles of vitamin C there were and thus how much vitamin C there was in the juice. And so here I'm just like struggling to get out the magnetic stir out of the starch solution. I was trying to do it from the outside and it was just weird. Turns out, you could just put the magnetic rod straight into the flask to get it out, so, awkward. So, part two, day two. I mean, now it's day two here, and continuing off where we left off with the starch solution and the iodide solution. And so I'm preparing for the titrations here. Using orange juice here, I used Great Value 100% orange juice made from concentrate. And you can see there I was also using vitamin C tablets, 500 milligram tablets, and to use that as some sort of baseline to judge to see how much air there was in my experiments, but unfortunately, apparently, it doesn't dissolve. The pill doesn't dissolve in water, even though I use a mortar and pestle to break it up, and so it didn't work. It's kind of awkward, but here I am starting up the titration here, and turns out it's nothing's going to happen no matter how much iodide solution I put in there because there really wasn't that much iodide in the solution actually. So it turns out that putting potassium iodide in water doesn't guarantee that you'll get potassium ions and iodide ions, which was kind of interesting to me because it's an ionic compound, so I would expect it to fully dissociate in water, but it didn't, so oh well there. So here we have the orange juice here, and it didn't work, so now I'm trying out just the indicators and all that stuff to see if it works. So I put in some starch and the iodide solution, and eventually figured out that the iodide solution was the culprit. And so there I added in hydrochloric acid and hydrogen peroxide, and this reaction pretty much guarantees that you'll get iodide ions, and then they'll form iodine. And so that was going the basis for the new experiment, which I'm doing here on the next day. And so here we're just setting up the titration yet again. And so this was a lot faster this time around because I was familiar with what I was doing. So for the analyte solution, I was using 5 milliliters of the same orange juice, 10 milliliters of the starch solution, and 150 milliliters of distilled water. Wait, did I say it? Yeah. And then 10 milliliters of hydrochloric acid and 5 milliliters of hydrogen peroxide. Both the hydrochloric acid and hydrogen peroxide are 1 molar. So, I said that wrong. Whoops. I put in 8.3 grams of potassium iodide, 10 milliliters of 1 molar hydrochloric acid, and 5 milliliters of 1 molar hydrogen peroxide into the flask, and I filled it up all the way up to 500 milliliters with distilled water. So that is my 0.01 molar iodide solution. And then for the analyte solution, I used 5 milliliters of the orange juice, 10 milliliters of the starch solution, and then I filled up to 200 milliliters with distilled water. And so there you can see the color change is pretty drastic. It turns pretty dark because when the iodine reacts with starch, it creates a really dark color. So based on that part of the experiment, it took about 4 milliliters of iodine solution to have the reaction reach its endpoint, or titration reach its endpoint. And so doing some ridiculous calculations there, turns out that I calculated there's about 2.66 grams of vitamin C in the entire orange juice container, which is 1.8 liters. And I was expecting, based on the nutrition facts, 576 milligrams of vitamin C. So I had an error of 362%, which really isn't too bad considering all the errors from measuring all the different substances. So not too bad there. I ended up, I ended up doing that first titration twice because first time was just test out to see the endpoint color, and then the second one was the real actual reaction titration. And so the second solution I did, if you didn't notice, was the vitamin C tablet solution, and that didn't turn out well because it didn't dissolve in water, so that was just a dud. And since I ran out of water, distilled water, I couldn't do any more titration, so that's all the data I have. But nevertheless, it was a pretty fun experiment. Learned a lot about making solutions and titrations and weird things that happen. Like, for example, I was expecting the iodine solution to be yellow because of the iodine, but it was actually really dark, so that was pretty weird. Anyways, that's going to be it. Thanks for watching. I hope you enjoyed. And again, this was my AP Chemistry final project.